So good morning to one and all. Screen is visible. Hello.
Yes, sir.
Okay. Roll number 14, 17, 52. So in the previous class, we have discussed about some issues of power qualities, what are the impacts and some importance of power quality we have discussed. And even we have also discussed about the power quality evaluation procedure. And in this procedure, what we have to do first, it is an existing problem or it is because of the new product problem, or what we have to impose that one we have to identify first. Okay, so we'll move towards the next topic, that is the same topic we will continue today for power quality evaluation procedure. It has some procedure to evaluate the power quality problem. How to evaluate problem and solution for that to improve the power quality. So according to that, yesterday only I told that one, anything normal operation is there, the fan and lights all are running normally. Suddenly some abnormal operation will start, some light will start to blink, the fan is off on, like that it is going to happen. Okay, so the problem will occur. That problem is because of what we have to identify first, that is, so because of the existing power quality problem, it is already the power quality problem is there, or this problem is occurring because of the new product, that is any design we have implemented, we have connected to that one, or any changes we have made in the connection, that in these three categories we have to identify. Number 81 and 54. Okay, so that is the first step. Next, to measure its characteristics, to analyze its characteristics, the measurement we have to do that. The measurement of the voltage, current, or concerned power quality, whatever the parameters are there, we are going to measure that one, and we have to analyze, we have to, what is that one, the characteristics of that problem, it is our existing system are being evaluated, or whatever it may be, that is problem because of what we have to identify, what parameter is changed because of that problem. The voltage is increased, or current is increased, or any frequency will changes, transients are there, interruptions are there, all the things we can characterize by using the measurement. Once the measurement start, then only we'll identify the way we are going to get that one, which parameter is varied over there. It may be voltage sag, swell, transients, impulsive transients or oscillatory transients, whatever sustainable interruptions or whatever, we are going to characterize by a measurement over there. Okay, next, when performing the measurements, it is important to record, we have to record that values, where exactly the problem occurs, at what voltage, what current, at what time, we have to do that one. To do that, the recording is important. For that one, they are telling we have to record the impacts of the variations here. Now same thing we have written here. Now the general procedure must also consider whether evaluation involves, this evaluation, it is involves an existing power quality problem or one that could result from new design. Existing power quality problem hai kya? Oh, it is a new design problem, or from proposed changes to the system here. Now instead of one lamp, I will connect two lamps over there. Because of connecting that, it is a proposed system, I have changed that one. So because of that, the problem is occurred, or what we have to identify. So that is the third one. Just a minute. Next one. The measurement will play an important role for almost any power quality concern. Any power quality concerns will be there. We have to measure that one. We have to check what variations will, which parameter variation occurred and all things. This is the primary method of characterizing the problem. The primary method to characterizing the problem is we should have the measurement, or primary characterizing the problem or existing system that is being evaluated. Which system we are going to evaluate, that system, we have to measurement, we have to do all the parameters measurement, and that measured parameter we should have to store that one. Then only it is easy to characterize it is native. When performing the measurements, it is important to record impacts of the power quality variations at the same time so that problems can be correlated with the possible causes. At particular time, if we have identified, then what is the problem, why the problem occurred, that one we can determine that one. Okay, so these are the method. Based on the procedure, I will tell that one. This is the procedure for the evaluation problem. First, we have to identify a problem. Next, we have to characterize. Next, identify the range of solution. Which range we have to do in the utility system or in the distribution, transmission, end user, where the integrated circuit is there or integration system is there or any equipment we have to, the problems occur. That one, the range of that solution or problem we have to identify here. Next, that is evaluate the solution. We have to evaluate based on that range. We have to evaluate the solution. And last one, we have to optimum the solution here. Now we have to evaluate economics of possible solutions based on this one. So identify the problem category. Whatever I told that it is because of in the existing system or because of the new product or design or by changing the normal supply system we have changed. In that one, which category it is? It is a voltage regulation problem, a deregulation, or a voltage unbalanced condition is there, or voltage sag is there, or interruptions are there, or flickers are there, transients, harmonic distortion. In this one, in this category 1, 2, 3, 5 category, in which category it is going to come, we have to going to identify first. First category of the problem we have to identify. Then we have to characterize that category here now. Suppose we are going to consider voltage sag and interruptions over there. So in the during the voltage sag, what will happen? The voltage will be decreases over there. So on that win, what is the causes for that voltage sag? It may be short circuit or it may be whatever that load increases and all the things. So we have to identify the causes first. So to identify the causes, the measurement should be there. How much load we have added to that line and what was the voltage during that situation, at what time the load is increased, at what time the load is decreased and sag is occurred. So all the measurement data we have to collect for the to characterize the problem here. So we have to find the causes, then we have to characterize, then we have to check that equipment because of which equipment the causes are occurred here now. So that is the second step, that is called problem characterization. Next, we have to identify the range of the problem here now. This problem, up to which range it is creating a problem, we have to identify. Up to the transmission side, that is utility transmission system or utility distribution system. Up to here only, it is not, it will not go to the transmission system. From here only, normally it is going to start utility distribution system. And then end user interface, customer interface, where we are going to do, that is in the meter or whatever in the transformer, that is end user system. It is nothing but your houses only here now in this system only. And equipment design or specification, particular equipment, particular device, we are going to identify only that much in that particular event only it is there or not. We are going to identify. Okay, if your mobile is get damaged, then we are not going to open the switchboards. That is because of your mobile only. Suppose I think you people have experienced, I don't know how many of you experience, घर में suppose फैन का कुछ काम रहते हैं, घर वाले बोल देते थोड़ा क्या हो गया, चलो देखो चालू नहीं हो रहा है, आप लोग ओपन करके कुछ तो गलत कनेक्शन दे देते, फिर हो गए बोल के चालू कर देते, ऑटोमेटिकली द सर्किट ब्रेकर विल ट्रिप. बिकॉज ऑफ दैट प्रोडक्ट के लिए सर्किट ब्रेकर ट्रिप हो रहे, आप उसके लिए पूरा घर का वायरिंग चेक करते क्या?
नहीं.
It is related up to that end user customer system only here now. That problem is up to the end user customer system only. That is related to you are the end user. We are using whatever the electricity, that is end user. So that problem is up to us only here now. And later where it is exactly to that product or equipment only here now. In that equipment only we have connected the wrong connection. Because of that the short circuit occurred. Because of short circuit, what will the transients are produced whenever the switch is on, transients will produce over there. Because of that transients, the current will increase. So whatever the MCB is there, it is going to break that one. who is having the basic knowledge, they will understand well about this subject. I'm telling frankly. If you don't know the equipment, if you don't know end user means, if you don't know the circuit breaker MCB, then you will not understand anything. You should have to know that one generation, transmission, distribution, all the things you have already studied. Okay. And you have already studied the switchgear and protection subject. Your power system analysis also you have studied. And devices we have studied, power electronics is over, IDC is over. So all the devices you have studied, for that reason only they have kept this subject in the fine layer. So that is identify the range of solution we are going to call that one here. Okay, suppose in the distribution system during the rainy season and all that one tree branch, it is fall down the cable. Because of that, the surrounding areas, all the peoples, they are going to suffer that one. They are going to get the power quality problems over there. They will not get power quality problems as well as the reliability also. If they will remove the supply, then the reliability indices we cannot, reliability will be reduces that one. Can say that one. That is related to the distribution system here. That is related to the distribution system. We are going to tell that one. So next, what we have to do, we have identify the problem, we have the identify the range of that one. So we have to start our evaluate solution. We have to start what is the problem. Suppose आपका fan or table fan में problem है, we have to do that one. We have to check what is the phase, neutral, where the winding is there, where the resistance is, stepwise resistance I have to reduce, like that we have to check that one. So modeling analysis procedure we have to do and evaluate the technical alternatives we have to do that one. Then the last step is optimum solution here. We have to evaluate economic of possible solution here. Now which one is less cost, that is economically possible solutions. The solution is there and it is economic. So that one we are going to optimize that one. So these are the steps for problem quality evaluation here now. Power quality problem evaluation here now. Any doubts here? If you have any doubts, you can ask. Yes. Londe Jairam. Jairam Londe.
Yes, sir.
What is the question? क्या पूछा मैंने? Why I am waiting? You tell me. Poonam Homkar. Roll number 11. Sakshi Kale.
Yes, sir.
I am waiting for the next explanation. फिर आप लोग नहीं सुन रहे फिर. Your concentration is not here then. I asked in this evaluation procedure, if you have any doubts, you can ask. आप लोग सुना ही नहीं दे तो फिर प्रॉब्लम कहाँ से आ जाएगा? डाउट्स कहाँ से आ जाएगा? Class strength is 66. Only 36 members were present. That is very good. Okay. Any doubts? Any one person reply is enough for me to go next. Try to give reply at least one person.
Yes, sir.
Okay. I asked any doubts. You are telling yes, sir. Is there any doubt?
No, sir.
No. Okay. Then we'll go for the next. That is, we have discussed yesterday. We have discussed some categories of the issues we have discussed. That is, because of the short circuit, lightning will be arises over there, and all the issues we have discussed by using the power electronics devices to control the controlling methods of the motors and all the things. Yes. So to those all the issues we have characterized in this following category here. We have categorized, that is different problems or issues which will comes under this category, and total 7 categories we have made that one. So in these 7 categories, different voltage sag will come, swell will come, interruptions will come, voltage unbalance will come, fluctuations will come, all the things it is going to define here. Now we are going to discuss here. So those categories are, first one we are going to discuss about the transients here. Now in this transients, what we are going to get, that is, what do you mean by transients? Switching transients are what? And impulsive transients and oscillatory transients we are going to get here. Now in this one we are going to discuss here now. And the impulsive transients, because of the lightning and all the thing, what will happen, suddenly one side the voltage will be increases and it is going to start to discharge like that. The transients is occurring here now. Next, the long duration voltage variation. How the voltage variations, normally we are going to call that one as what is that, under voltage and over voltage, we are going to call that one under voltage and over voltage. If the over voltage for more than 1 minute is there, then that is the sustainable interruptions we are going to call that. What will happen if the more than 1 minute the problem is occurred, then the person you have to visit to the problematic place and you have to repair that part. Otherwise automatic the reclosing will not occur over there. So those periods we are going to call as long duration, means 1 minute. You just think that 1 minute is long duration voltage variations, we are going to call that one. In this category we are going to discuss over voltage and under voltage we are going to discuss. Next, short duration voltage variations. This one, in the short duration, for the small duration about 0.3 microseconds or 0.1 microseconds also we are going to call that one. Cycles in the form of cycle, 1 cycle and 0.3 cycles, 30 cycles, like that we are going to discuss. That is nothing but voltage sag, swell, it will comes under this one. Interruptions, it will comes under this one. Voltage imbalance or unbalance we are going to call. Waveform distortion we are going to call that one. Waveform, what is the DC cutoff, how the frequency is there, and all the things we are going to discuss here. Waveform distortion and voltage fluctuations, power quality variations we are going to discuss. So these total 7 categories are there. So all the power qualities issues are comprised here in the 7 categories here. So one by one we are going to discuss now. So first one, I will take the transients here now. So the term transient is nothing but it is long been used in the analysis of power system. So what it is, nothing but suddenly what will happen, you are going to apply one heavy load switch. I think in your houses you have experience or not, I don't know about that one. If you all of you have a syntax in your rooftop of your house, syntax hai kya? Yes.
Yes, sir.
Yes.
Whenever you will switch on the motor of that to pump the water to the syntax, you can observe your lighting system. Suddenly it is going to blink over there. Down ho jate thoda brightness. Observe kiye kya aap?
Yes, sir.
So that is the problem only, na? That is transients only they are producing in impulse. Transients. That is switching transients. We are going to call that one. Heavy load we are switching. Because of that one, what will happen? All the power supply, because of heavy load, the voltage is going to down. For that reason, your brightness of the light will be blinks over there. For fraction of second, you have to observe. It is not more than 2 seconds or 1 second also. Within a fraction of second, it is producing over there. That is called transients. We are going to call that. That is called transients. So the term transients has long been used in the analysis of power system. It is not a new word, that is transients. From long been we are using this word that is called transient in the power system variation to denote an event that is undesirable. That is called undesirable and momentary in nature here. For a particular moment or particular instant, it is going to come that one here now. So undesirable, that is transients are undesirable here now. The nation of a damped oscillatory transients due to RLC network here now. That is resistive inductive capacitive network is probably what most power engineers think of when they hear the word transient here now. It will becomes under RLC circuit only. See, सब लोग घर में यूज कर रहे हैं. This is RLC load we are using or only resistive load we are using? We are using only resistive load or resistive inductive capacity loads we are connecting here in your houses. Anyone? Just a minute. Okay. So the RLC network in your houses, we are going to use combination of resistance, inductance, capacitance only. It is going to operate in the form of impedance load for the AC. We are using impedance load or resistive loads. Anyone can tell that one answers. Yes.
सर पता नहीं है सर.
पता नहीं है. आप तो अभी क्या है इलेक्ट्रिकल के ऊपर कंसंट्रेशन करने का बंद किए मैडम आप.
In a household application, there is resistive load.
Okay, what is the lamp? Lamp is which type of load it is?
Resistive.
What about your fan? Fan. Inductive. Then what about if you have an inverter supply and you are charging the battery?
Capacity.
Then what happens here now? We are using RLC load or only R load?
RLC.
That is the thing, na? This is very basic. You should have to know in the first year itself. You have studied the AC circuit for the pure resistive, pure inductive, pure capacitive, combination of RL circuit, RC circuit and RLC. मैंने remind कर रहा हूँ. I am reminding you all people. In the first year you have studied all the things. Study किया क्या RLC circuit?
Yes sir.
Yes.
So wherever the RLC circuit is there, the transients are common. They are telling that one here. The nation of damped oscillatory transients here now. These oscillations are there. We are going to damp by using some damping equipments as whatever that one components by we are using now. So oscillation damping we are going to call that one here now. To an RLC network is probably what most power engineers think of when they hear the word of transients here. Whenever they are going to hear the word of transients, that is because of RLC network only they are going to tell that one here. So there are two types of transients are there. One is impulsive transient, another one is oscillatory transients here. So this is a sudden, we are going to call that one undesirable, we are going to call that one here. So one by one we'll discuss. I will give some examples also. I'll give. See here, this is the impulsive transients, we are going to call that one here. So here transients is nothing but suddenly it is going to occur. The lightning, we are not expecting anything here now. Suddenly the lightning will strike. Because of that one side the voltage will or current, it is going to increase that one. It is going to increase over there. Suddenly it is going to transients will be occurs over there. So that is called the impulsive transient is a sudden non-power frequency. It is not non-power frequency. Normal power frequency is 50 hertz, but it may be 200, 500 hertz frequency. It is going to vary here now. So non-power frequency change in the steady state condition of voltage, it may be change in voltage or it may be change in current or both, that is unidirectional here. Now it has one character, the impulsive transients, that is unidirection. If it is previous go to the upside or it is going to the downside here. Now it may be positive side or it may be negative side. One side it is going to move that one. It will not go that one. Pahla starting when it will strike, it will go up positive side, then it will go negative side, then it will go positive side. Like that, it is not there here. It is only once it is went to positive here, means within fraction of some second, what will happen? It is going to come half of that one here. Now like that, it is slowly decreases here. That is called impulsive transients. We are going to call that one. Impulsive transients we are going to call. Example I will can give here. See here, आपके घर में suppose in the kitchen you are getting the water in the tap. Yes, tap में water आ रहा है. You want to shift that one. The cooler को आप पानी भेजना है उधर. उसके लिए क्या करते हैं? आप एक पाइप लेके उसको कनेक्शन करते हैं. Yes or no?
Yes.
कनेक्शन करते मालूम है ना? So ऑफ करके आप टैप ऑफ करके आप पाइप कनेक्शन करते हैं. Suppose you keep it on and try to connect that one here. एक साइड सपोज आपका साइड नहीं आना बोल के पहले आप साइड का उधर ज्वाइंट करके उस साइड में वन साइड इट इज गोइंग टू फ्लो द वाटर. Yes, like that we are going to already the normal power supply, it is going here now. Normal power supply, it is going from the higher voltage side to the lower voltage side. Suddenly the lightning strike will occur over that. So based on the flow of that one, if here the higher voltage is applied, some voltage will flow here, some voltage will flow here. That is undesirable, but it will go in one side only. If it is positive side, then it will go positive side only. It will not come to the negative side. That for that reason only impulsive transients we are going to call. If the sequence, whatever the frequency is there, non-power frequency, so change in voltage or current, positive to negative, like this, it is going to come here now. Suddenly high and slowly medium and slowly low. That is called oscillatory transients here. There is no much difference between impulsive. This is the impulsive. It is a unidirectional. If it is primarily, it is from negative to negative mein hai abhi. It is in the negative side only. Same we can try in the positive side also here now. Suddenly what will happen? From 0 say it will go high and it will come, sorry, it will go high and like this it is going to decrease here now. It is going to decrease like this here. This is positive side, this is negative side. It may be in positive side or negative side. Only one side it is going to move that one. So an impulsive transient it is a sudden, that is suddenly the power voltage or current it is increased here now. Sudden non-power frequency, it is not 50 hertz, it may be more than that or less than that here now. Non-power frequency, the power frequency of India is 50 hertz. In the foreign country 60 hertz we are going to refer here now. So non-frequency change in the steady state condition of the voltage here now. The steady state means final value here now. That is steady state condition of, it may be voltage or current or both here now, voltage and current here. So whatever this sudden change is the transient, it is unidirectional in polarity here. Unidirectional in polarity, that is negative is there means negative only it is going to close. Positive means positive only it is going to close here now. Primarily either positive or negative we are going to call this one here. So this is impulsive transient we are going to call this is impulsive transients. Example we will take that one here now. So impulsive transients are normally characterized by their rise and decay times here. Suddenly what they are doing here now, they are going to rise here now and they are going to decrease slowly over there. So these are characterized by their rise and decay times here, which can also be revealed by their spectral content here now. Whatever the content is there, spectral content from here to here, that one, that is revealed by their spectral content we are going to call. Example, we will take that one. Just a minute. 6. Spectral content, it is revealed by that one here. See, for example, I will take one example here now. You just see that one. I will take one example. A 1.2 into 50 microsecond here. 1.2 50 microseconds. 200 volt is its magnitude. Voltage magnitude is 2000, not 200. Sorry, 2000 voltage is there. Suppose impulsive transient nominally rises here. Now, impulsive transients, what will happen? I will take here. Here, this one. I'll take which color? Blue color. Impulsive transients from here I will consider as this one as 1, 2, 3. Visible है क्या ये? 4. इधर ड्रा करो क्या? विजिबल है क्या नहीं?
विजिबल है सर.
एक मिनट, इस साइड में ड्रा किया तो अभी विजिबल है क्या? नहीं है, पहले वाले ही ड्रा करेंगे. ठीक,
पहला बेटर था.
so this one here now I will consider as this is 1 microsecond, 2 microsecond. It's nothing but just 1 भी नहीं लेने का, इसको directly 1050 लेता हूँ मैं. This is 10 microseconds. This is 20 microseconds. 40 microseconds. 30 na. 30 microseconds. 40 microseconds. And 50 microseconds. Like this will go here up to the, that is infinity. Here I will write this one as 100 microseconds here. 100 microseconds. Okay. Here I will consider as this one 100, 200, 300 like that. We are going to consider here now. That one also I will write. Just a minute. वो भी समझ में आना चाहिए ना. So I will consider here. This is 500. The y-axis I will consider as 500. That is 1K, 1 kilovolt. That is 1.5 kilovolt. And this one is 2 kilo. 2 kilo is nothing but 2000 only, na? Yes or no?
Yes.
Rule number 6 and rule number 31. Okay. So 2 kilovolt here now. What I will do here, I have considered that 1.2 and 50 seconds I have considered here now. Initially at 1.2 seconds, it will go to the 2000 volts. That is nothing but 2 kilovolt. It is going to 2 kilovolt. The voltage it is going to rise here. That is impulsive transients. The positive side we are considering here now, unidirectional. Slowly what will happen here, only it will take the spikes here now, and it will start to decrease us like this. It is going to not slow, suddenly it is not going to decrease. So what will happen, like this it is going to decrease here now, and it will come to here now. So for 1.2 seconds it is going to reach here now. In that impulsive transients, nominally it will go to the rises to 2000 volt here now. Whatever the steady voltage is there, it is going to rises over there, and slowly what it will do, it is going to reduce half of that one, 50% of maximum value, that is called 1K at 50 microsecond here. At 50 microsecond means, see here, what is the voltage here now? You can observe that one here. So sorry, it is almost, I have drawn roughly here now. 50 seconds, it is 1 kilovolt. So 2 kilovolt ka 2000 divided by 2, how much it is? 1000 only, na? 2000 का half 1000 हो गया क्या नहीं? वो भी मालूम नहीं बोलते. So
Yes,
like
sir.
that, for here the example we have given here now, 2000 volt we have considering this one, 1.2 into 50 microsecond, 2000 volt we have considered. Impulsive transient nominally rises from 0 to its peak value of 2000 volt in 1.2 microsecond here. Only 1.2 microsecond may it is going to up to the 2000 volt, it is going here now, and then decays to half of its peak value in 50 microseconds. It is going to start to decay or delay, or it is going to start to decrease to the 50% of this peak value. 50% of peak value means 2000, the 50% it is 1000 at 50 microseconds here. It is 50 microseconds, it is decreasing. Next 50 microsecond it is going to come to the towards zero here. Like that we are telling that. So only one thing you have to remember here, it is unidirectional. Primarily it will start from negative, means it will be stay in negative only, and if it is positive then it will flow in the positive only here. Like that we have to think that. That is called impulsive transients we are going to call. But the oscillatory transient is different than this here. The oscillatory transients, the causes here now, the most common cause for this impulsive transients are nothing but lightning only here. The lightning only, it is a causes here now. See here, during the normal operation, our voltage will be in this condition here now. See here. Sinusoidal wave रहते voltage का? Yes or no? Voltage is under sinusoidal wave only ना? आवाज आ रहा है क्या? अनम्यूट किया मैंने, म्यूट किया क्या नहीं? Hello? Is it audible? Hello? Anybody, can you reply please? Is it audible or not?
Audible, sir.
Internet connection gaya tha kya? Okay. So normally the AC supply voltage waveform is sinusoidal here now. Whenever the lightning will occurs at during the positive half cycle, in this positive cycle only the transients will occur, that is impulsive transients will occur here now. During the negative half cycle, it is occurred in this negative side only, the impulsive transients will occur here. For that reason we are telling that one, that is a unidirectional it is going to do. If it will start from negative, means it will be stay negative. Positive means positive, it is going to stay here. So it is normal common cause of for this one impulsive transients is nothing but lightning. Now we have solved this problem by using the lightning arresters in a substation and all the things. Already some little bit we have solved. Still also in the whatever the customer side, we have to do work on this one. So many researchers are doing their efforts and they are identifying products and all the things over there. For that reason only they are telling that one, every house should have the earthing facility. Earthing facility should be there over there. For the leakage purpose they are telling. Then also whatever the over voltage and all the things, we can bypass that one later. Okay, this is impulsive transients. Next, the oscillatory transients is there. That is what you are expecting, that is oscillatory transients here. It is also a sudden and non-frequency change in the steady state condition of voltage, current, or both here. But it includes both positive and negative polarity values here. It includes both positive and negative polarities. It is going to include over there. See here we are considering that one here now. The oscillatory signals, what it will do, suddenly it will increases into the steady state value of positive, negative, it will fall again, it will go positive, negative, again it will fall, like this. It is going to come from higher value to the lower, then slowly it is going to do like this. It is like this here. So this is oscillatory. It has some high value, medium value, and low value here. This is oscillatory transients, we are going to call that. But it is unidirectional now. It consists, it is flowing from positive to negative and negative to positive, it is flowing here now. The impulse will be unidirectional, but the oscillator will be bidirectional, we are going to call that one here now. An oscillatory transient is a दीपक तो अभी ज्वाइन हो रहे हैं, क्लास खत्म होने के बाद अटेंडेंस ले रहे बोल के मालूम हो गया अभी उनको. An oscillatory transient, where white color is okay, is non-power frequency change in the steady here now. So the frequency is changing here now. Suddenly it is going up, down, and all the things here now. So non-frequency change in the steady state condition of voltage or current are both, that includes both positive and negative polarity values here. That is nothing but it is a bidirectional, it is going to move here. An oscillatory transient consists of a voltage or current whose instantaneous values changes its polarity rapidly here now. Its polarity changing, here the positive is there. Sorry, here the positive is there, here negative is there. Polarity changing or not? So it is described by its special spectral content, that is predominant frequency here now. This one we are going to call as predominant frequency, that is called duration, and the magnitude here now. So duration, based on the duration, like a duration increase, the magnitude of this one it is start to decreases here now. So the frequency ranges for these classifications are chosen to coincidence with common types of power system oscillatory transients phenomena. That is called here the spectral content subclasses here now. This is class high. This class high we are going to call. This is class medium we are going to call. This is class low frequency mid content we are going to call here now. So spectral content total is spectral content. It has subclasses, that is are high, medium, and low frequency here now. It has high frequency, low frequency, and medium frequencies are there here now. See example I can give. This is the actually diagram it is there. एक कुछ तो अभी in the house openings and all the times you may given any gifts and all the things. Just a minute, I will hold this mouse here. What it is normal steadily it is there here now. When I will push that one, it is not going to stop over there. Slowly time consuming, it will stop to reduce its width and it is going to stop over there. Yes or no? Like this, if the transients occur here now, it will not come to the normal suddenly here now. It will go up, low, high, low, positive, negative, and slowly it is decreasing here. They are decreasing here or not here now? The magnitude is decreasing here now. The current is decreasing here. In the form of it is decreasing here now. Both positive and negative values are decreasing here now. It will come to the zero after some duration here. This is called oscillatory transients we are going to call it. Okay, oscillatory transients. That is, there are only first one we have finished. Next we will go for that is long duration voltage variations. Long duration means आपके हिसाब से कैसे 1 hour class is long duration, but for the electricity 1 minute is very long duration. We are going to call that one. Only 1 minute is long duration. We are going to call that. So the long duration variations encompasses RMS value or RMS deviation or variation at power frequencies for longer than 1 minute. The frequency will be 50 hertz only, but whatever the RMS value is there, it may go up or it may go down for longer than 1 minute. If more than 1 minute, that one we are going to call as long duration variations. We are going to call that one. If it is more than 1 minute, that is called longer duration voltage variations we are going to consider. So voltage variation क्या हो सकते हैं? एक higher voltages or lower voltages. We can call that one. That is called higher voltages is nothing but over voltage. Our requirement is 230 volts. Okay, 230 volt is our requirement. Suppose it went 260 volts for 1 minute, more than 1 minute, 260 volts, and it came to 190 volts for 1 minute. That is, this is under voltage, this is over voltage we are going to consider. Instead of 260, that is percentage we are going to call this 230 is 100%, then more than 110% or less than 90% is there. That is called less than 90% of the standard voltage, that is called under voltage. If more than 110%, that is called over voltages. We are going to call that one here. So ANSIC 84, that is called American National Standard Institutes. We are going to call that one American National Standard Institutes. According to that, the Institute Standard Institute, it specifies that the steady state voltage tolerances expected on power frequency. Whatever the steady state tolerances are there, it is expected on power system. A voltage variation is considered to be long duration when the American National Standard Institute limits are exceeded for greater than 1 minute. Here, whatever they have, according to your textbook, they have referred that journals and all the things. So yeah, they have considered here now. So if you are considering the India and IEEE standards also, if it is longer than 1 minute, the voltages or limits are exceeded. That is the limits here 90 is there, here 100 is there. Okay, 90 to 110. If it is less than 90 or greater than 110, that is called, that is variation of voltage only we are going to call that one here. Longer than 1 minute. So the long duration variations can be either over voltages or under voltages here. Here there is two options only. It may be over voltage ho sakte and it may be for under voltages, it can occur over there. So the combination of this over voltage and under voltage we are going to call as voltage unbalance. That is we are going to discuss in the later part here. So the over voltages and under voltages generally are not the result of system faults here now. These are because of the over voltage will not be occur because of the faults, and the over under voltage will not occur because of the faults. As per our normal operation only, during the load on your houses, you are going to switch on the fan, motor and all the things. Based on this, it is going to occur here. It is going to occur. Suddenly the heavy load I am going to set down. Then the voltage will be, load will be reduces. It may go for the upper voltages, over voltage it can go. If the load is applied, suddenly I have added heavy load, then the voltage will be reduces over there. That will come under voltages. Like that, it is not a fault. Because of not fault, it is not going to occur because of, but are caused by load variation here now. These all are caused by load variations on the system and system switching operations here now. In this system only, because of switching operations, by variation of load, this over voltage and under voltage will be occur. Such variations are typically displayed as plots of RMS value versus time here now. For particular RMS value and time, it is going to plot over there. Sure, still 8 minute time is there. Okay, see here, over voltage is nothing but what? An over voltage is an increase in the RMS AC voltage greater than 110% here. If it is greater than 110% at power frequency only, there is no change in the frequency also. Only the value of voltage is increased, that is more than 110% here. Now greater than 110% at power frequency for a duration longer than 1 minute. If the voltage is increased more than 110% at power frequency, but longer than 1 minute, then that one we have called as, that is over voltages we are going to call it. When the over voltages will occur here now, switching off a large load here now, or energizing a capacitor bank here now. Suddenly they are going to energize the capacitor bank here now. Incorrect tap setting off on transformers here. Especially I will explain you people, switching off a large voltage here. See, in your houses only I told example I have taken previously. Suddenly the motor on किए तो lamp का brightness कम हो जाएगा, off किए तो suddenly bright हो जाएगा. Yes or no?
Yes, sir.
So that is because of under voltage and over voltage only here now. We are considering just for understanding purpose. I am taking your examples, your house examples. When you will go to the distribution side and transmission side, all the area, whole area, by considering that, suddenly in the morning period, in the residential only you consider that one. Morning period, everyone they will switch on the, what is that one? Grinder, washing machines, and the, what is, fridges, mixer, grinders, all the things they are going to switch on that one, heaters and all the things. So in the during the morning period, it is going to increase. In the residential areas, in the afternoon, there is no, especially in the night period, nothing was on over there, only except fan only. Fan or AC we are going to call that one. So during the morning situation, they will not understand who has switched on which load and all the things. On that condition, it will comes under over voltage. And in the afternoon session, what will happen? Suddenly they will to go to the office and hurry in that situation. They will switch on everything. So suddenly what will happen? Voltage will be increases, because switching off is nothing but remove the load only. Na? We have switching off a large load over there. like that in the industries, especially everyone Monday to Friday, they are going to start their manufacturing and all the things. They are going to increase the load on that situation suddenly on the Saturday. So in the Friday evening, they are going to switch off all the loads of that one. So on that situation, the voltage will go higher there, more than 1%. If it is longer than 1 minute, that is called over voltage. We are going to call it. That is over voltage. In the reverse order, if an under voltage is a decrease, here increase the, now in the under voltage is nothing but decrease in RMS AC voltage to less than 90%. If it is less than 90% at same power frequency for a duration longer than 1 minute. For less than longer than 1 minute, the voltage is reduced, then that is called under voltage we are going to call. This will happen because of sudden on off the load, sudden switching of the load. Suddenly we are going to add the load over there. So because of that, it is going to occur. A load switching on or capacitor bank switching off and overloaded circuits, we are going to call that. Any doubts here? You can ask anything. Is it clear? The concept is very simple here.
Yes,
Longer
sir.
than 1 minute, that is called, the load is removed longer than 1 minute, that is called over voltage. If load is added suddenly, if the voltage is less than 90% for longer than 1 minute, that is called under voltage we are going to call. If it is over voltage and under voltage, if it not come to the normal voltage before 1 minute, then that whatever the interruptions we have added the load, that is called, we are going to call as sustained interruptions. We are going to call that one. Sustained interruptions we are going to call them. We are going to use a term that is called brownout. We are going to call is often used to describe sustained period of under voltages initiated as specific utility here. Now, what we are going to tell here now, when the supply voltage has 0, suppose suddenly it will decreases to 0 due to some interruptions. Okay, decreases for longer than 1 minute. If more than 1 minute, if it is decreased, then what we have to do? We have to go and personally we have to check that one. I will give one example. मैं एक example देता हूँ. You can analyze that one. Auto recloser बोल के नाम सुना है क्या नहीं मालूम नहीं. I don't know. During the rainy season only you can check that one because of heavy air velocity and all the things. The supply, what it will do, suddenly it will go off and suddenly it will come back. Experience किए क्या? Suddenly it will go off and suddenly it will on. Again it will go back and again it will come. Again it will go back, but it will not come back. Have you observed? I don't know. ऐसे एक्सपीरियंस हो गया क्या किसी को? घर में आप रेनी सीजन में स्पेशली लाइट ऑन ऑफ होते रहते हैं. यस सर नो? बट लास्ट
होता है सर.
थर्ड टाइम ये ऑन होके ऑफ हो गए ना, वापस नहीं आते 10-15 मिनट, एटलीस्ट 5-6 मिनट वो नहीं आ जाएगा. That is called, the problem is that interruption is sustained interruption. So the person physically they have to check and they have to repair that part. So that is called sustained interruptions we are going to call. The auto recloser, what it will do, if the problem is that is temporary, यानी कुछ तो फेड गिर गए, उसको temporary branch है, वो wash out होने तक क्या करते, it will reclose again. Then also the problem is same condition, then again it will off, then again it will reclose. The third time it will not reclose that one. The person, the way they will visit the problematic place and they are going to repair that one. I will read this one, just a minute. When the supply voltage has been 0 for a period of time in excess of 1 minute, if excess of 1 minute there is no supply, then the long duration voltage variation is considered here. This is also long duration voltage variation is considered a sustained interruption here. Now, voltage interruptions longer than 1 minute are often permanent here. These problems are permanent and require a human intervention to repair the system for restoration here. We have to, human being physically they have to repair that part here now. So this one, the term sustained interruptions refers to specific power system phenomena and in general has no relation to the usage of the term outage here now. So what we have told here now, the sustained interruptions will also come under long duration voltage variation only. We have considered that one. If it is greater than 110% and less than 90%, we have considered. Suddenly it is 0 for more than 1 minute, then we can think that the interruptions whatever occurred because of sustained interruptions are there. The humans physically they have to repair to restore the power system that we have discussed here now. So these 2 points, transients and long duration voltage variations, we will have discussed, and tomorrow we will discuss about the short duration variations and other terms we will discuss in the next class. What is this one? Other terms: short duration voltage variations, voltage imbalance, waveform distortion, voltage fluctuations, power frequency variations. These are all the things we will discuss in the next class. I'll stop here only. So absent numbers I will call: roll number 2, roll number 10, roll number 7, roll number 29, 30, 32, 35, 37, 41, 42, 44, 45, 46, 47, 48, 49.
सर 29 present.
29 present है क्या?
हाँ
50, 53, 55, 56, 59, 60, 61, 62, 63, 64, 65, 66. See nothing.
52 present, sir.
Huh?
52 present.
54 present.
52 present है, 52 present ही बोला ना, 54 भी present ही बोला मैंने, 51, 53 बोला है. See, you have to maintain the attendance. I will show the report of this Zoom meeting. I will get the detail at what time you have joined, what time left किया था, फिर वापस कितने बजे को ज्वाइन किए, कितना ड्यूरेशन तक आप मीटिंग में था, याद रखो. Okay.